So let us deal with the projectile motion segment for the essential Irodov series. This is the first problem in this segment, and it is problem number 1.10. So if we state problem number 1.10, then the problem is stating two bodies were thrown simultaneously from the same point, one straight up and the other at an angle theta equals 60 degree to the horizontal. The initial velocity of each body is equal to 25 meter per second. Neglecting the air drag, find the distance between the two bodies 1.7 seconds later. So if we first of all express the two different motions diagrammatically, then we can draw it this way. So this is the first motion's description, and this one is the second motion's description. So in case of the first motion, it is said that the particle is projected vertically up from this point, and it is projected vertically up with a speed of 25 meter per second. So if we designate this one as x-axis and this one as y-axis, so it is having an initial velocity of 25 meter per second in the upward direction. The value of acceleration due to gravity is in the downward direction in the negative y direction. In the second aspect of motion, we again have a x-axis and a y-axis, and this time the particle is projected with a speed of 25 meter per second, making an angle of 60 degree with the horizontal, and the acceleration due to gravity is acting in the downward direction. So in the second scenario, it is bound to move in a projectile path. The problem is asking us to calculate the separation between them 1.70 seconds later. So if we write the initial velocity v1 in this case, so v1 can be written as plus 25 j cap meter per second, and if we write v2 vector, then v2 vector can be written as 25 cos 60 I cap plus 25 sin. Then we can solve it as 12.5 I cap plus 21.65 j cap meter per second. So these are the two velocities that we have. If we calculate the relative velocity v12, then v12 can be written as v1 vector minus v2 vector. So v1 vector minus v2 vector turns out to be minus 12.5 I cap plus 3.35 j cap meter per second. If we talk in terms of acceleration 1-2, then it is equal to a1 vector minus a2 vector. Since both of them have same acceleration, so the value a1 vector minus a2 vector turns out to be 0. So therefore, after a duration of 1.70 second, the relative separation between them is equal to magnitude of 1-2 times t. So magnitude of 1-2 is equal to minus 12.5 square plus 3.35 square root over times 1.7, and it is approximately equal to 22 meter. So this is the correct answer for this problem that we solved.